But according to you, is it going to be the best model? Well, that's what we're going to figure out very quickly, because then we're going to run all the cells here for the polynomial regression. There we go. As you can see, it's going very fast. And well, for the polynomial regression model with, remember, a degree of 4, we get a final R-squared coefficient of 0.9458. So we already beat our multiple linear regression model, and therefore so far the best one is polynomial regression. Feel free to actually test some other degrees if you want. But now we're going to move on to support vector regression and see if it's going to beat the polynomial regression. I actually really like this model, and usually I get the best results with this, but let's see. Let's run all the cells, and in Flashlight we'll get the final performance. No, not yet actually. And by very, very short, it beats indeed the polynomial regression model, 0.9480, and here we had actually 0.9458. So far, the best model is the support vector regression. Can you see how we're going super fast here, right? We only had to change the name of the dataset here, and all the rest is automatic. And that's the beauty of code templates. Now let's move on to the next one, decision tree regression, and let's see if it can beat the support vector regression, which remember has 0.948. So let's see, let's run, all the cells, and the final result is 0.922. Okay, so that's actually the worst. I think it is indeed worse than the multiple linear regression. Yes. So the decision tree regression model did not perform well here, but maybe that's because it didn't have enough team spirit to tackle these predictions. And that's what we're going to figure out with random forest regression, because indeed a random forest regression model is a bunch of trees teaming up to return an ultimate prediction. So now the ultimate question is, do you think that the final winner of this competition is going to be the support vector regression model or the random forest regression model? Take your bet and let's see if you're right. So there we go. We're about to find out in a second, because we're going to click run all now, and we're going to get the final result with a final R-squared coefficient of actually 0.96, which therefore makes the random forest regression the big winner of this data competition. So congratulations, in a very few seconds you were able to quickly identify and select the best regression model, and mostly, the most important thing in all this is to finally know how to answer this very often asked question: how do I select the best model? And well, the answer is you simply try all of them, and using the R-squared coefficient, you compare them and conclude on which one is the best. And in our situation here, for this data set, well, the best is the random forest regression. All right, so congratulations. Now you know a lot. You have an expertise in regression models. You not only know how to build them, but also you have all these code templates, which you can use very efficiently to select the best machine learning model for your regression problem, and that for any data set. And remember, if your data set has missing data or categorical data, well, you only have to grab your tools in the data preprocessing toolkit to handle these situations, and then you can deploy your code template. All right, so I'm super excited and super happy now that we completed 100% this part 2 on regression. And now, my friends, we're going to move on to a brand new branch of machine learning, which is classification, and which we're going to do exactly the same, but this time to predict a category. And same as what we did for this regression branch, well, we will build several classification models, and at the end, I'll show you again how to select the best one. So I can't wait to see you in this part 3, and until then, enjoy machine learning.